Hi everybody, this is Fisher Coder here. Today we're going through LeetCode problem 15, threesome. Before we dive in, just do me a favor and smash that like button and don't forget to subscribe our channel, which is dedicated to provide LeetCode tutorials and to help software engineers or computer science majors to prepare better prep for software engineering interviews and ace through coding problems. With that said, let's dive deep into today's problem, threesome. This is basically a derivative of twosome. So, and it's adding a bunch of new constraints or conditions. If you remember twosome, we were basically given an array of integers and a target number. So for this problem, we're given an array of integers still, but the target is 0. And it's asking us to find whether we can find 3 numbers instead of 2. So it's called threesome. So let's go through this problem together. Given an array nums of n integers, are there elements a, b, c in nums such that a plus b plus c equals to 0? Find all unique triplets in the array which gives the sum of 0. So it's asking us to find all unique triplets. Pay attention to the word unique, because we like say there's a note here. The solution set must not contain duplicate triplets. So we would like to rule out all possible duplicates. A very obvious follow-up question to ask if you get asked during a real interview for this question is, will there be any duplicates in this given array? So for example, in the given array here, is it possible that we will have any possible duplicates? Now looking at this example, we know apparently there are duplicates, but when you get asked during a real interview, either outside or phone screen, especially when you were not given an input, you would like to clarify the ambiguity with your interviewer and say whether there's any duplicates in the given array. So apparently there is in this case. For this one, a possible solution set is no. The only the only solution that contains all unique triplets is this solution set, right? So how do we tackle this problem? The difference between this threesome and twosome is that now we're required to find 3 integers. So at least we need to have a nested for loop, right? Because we need to find 3 elements in this given array that sum up to a target number. In this case, the target number is 0. Looking at this problem at first glance, a very straightforward or even brute force, I would call it a brute force solution, which is to have a 3-layer nested for loop, right? To go through this given array. Because we're required to find all 3 elements, we're required to find all unique triplets, right? So this 3-layer nested for loop is going to be looking like this, blah blah blah, and then another layer which is I plus j starts from I plus 1, and then another one ijk starts from so basically at first glance, this is the very brute force solution, right? Since we're required to find all unique triplets, it's going to be 3 elements. And then say we'll do if, so int sum equals nums I plus nums j plus nums k. If sum equals 0, we do something else, right? We'll just add this nums I, nums j, nums k into array, and then we'll just keep iterating through this. Of course, this is a brute force solution and it's a working solution, but I'm pretty sure it cannot be accepted by LeetCode OJ and by any of your interviewers, right? This time complexity is gigantic, it's brutal. It's going to be O, big O cubic, right? I mean, O n cubic is it's really, really brutal. I don't think it's going to be an acceptable solution for any interviewer. So we'll think about how we can better or improve this, right? This is given an array. Possibly there is duplicates. So we might have gone through the same combination of the triplets many, many times. How can we avoid that? How can we just avoid going through all of the duplicates again and again? One simple way is that naturally comes into mind, which is to sort this given array first. Let's reset it, right? So we can sort this given array so that every element in this array will be in sorted order from the smallest to the biggest. After that, we can just check if there are any duplicates. The duplicates must line up together. They must line up together, right? Say -1 will be together, and then 0, 1, 2. Oh, so -4 is the first, and then -1, -1, they stand together, and then 0, 1, 2. So when we find -1, there's a following same element, -1, right behind it. We can just skip it, right? This is the idea. Then we talk about the sorting algorithm. Common sorting algorithm, or like the most of the language default implemented sorting algorithm, is going to take you nlogn time. This is still much, much better than n cubic time, right? Way much better. So after sorting this algorithm, what else can we do? We can have a 2-layer nested loop. That's it, right? Basically, we have 3 pointers. One pointer is going to be at the very beginning, and then move towards from the very right, and then we have other 2 pointers, but the other 2 pointers will be a little bit different, especially the third pointer. The second pointer is going to be the first pointer plus 1, but the third pointer, we're going to move that from the very right end, right? Why can we do that? Because we are working on the array that is sorted already. So we know the most right pointer is going to be pointing at the current largest element that is possibly to be part of the triplet. So with that said, that we can only have a 2-layer nested loop, which is going to be O(n) squared, right? So this is still much smaller than O(n) cubic. This one, O(n) squared, is much bigger than nlogn, but so the upper bound of these two is going to be nlogn. So the final time complexity of the algorithm we are about to code up after solving the algorithm is going to be O(n) squared, which is much smaller than O(n) cubic. That's the beauty of algorithms. With that said, we can start coding up the actual solution, right? All right. Let's erase all of these. I hope you guys are following along. If don't, please leave me comments down below. Just copy this result array list. So here, first, as I said, we're going to sort this array sort nums, and then we'll have a for loop. This is the most outer for loop is going to be, we start from 0, start from nums length. We actually cannot go to the very end because we are asked to find triplets. So we'll go through the last third element. That's for the first pointer. So remember, we are going to have 3 pointers because we need to find 3 elements for every single triplet. So here, first we need to pay attention to duplicates, right? We want to remove all of the duplicates because it's asking us to return all of the unique duplicates. We don't want to return any, include any duplicates. So how do we avoid duplicates? We'll check if I is greater than 0 and nums I minus 1 the reason we check I greater than 0 is because we want to compare two elements, whether they are duplicates or not. How do we compare two? One way is to have I minus 1, right? Not equal to, if they are equal to I minus 1, we'll just continue, right? What is this case? This case is like, given this array, minus 1, minus 1, minus 1, and then 0, 1, 2, right? In this case, minus 1, minus 1, these three are all duplicates, and I greater than 1, so we'll just continue. We don't need to do the same math, do the same computation for all of the three minus 1s. We only need to do it for one of the same elements, one of the duplicate elements. That's it. That's for this use case, for this test case. Afterwards, what we will do is that we'll create, remember I said we need 3 pointers. Now we're going to have another 2 pointers, which I'm going to call it left and right. Left is going to start from I plus 1, and right is going to start from nums, the very right end, right? It's going to be this. So now we're going to have another loop inside of this for loop, which is shrinking from, we are crushing this, the remaining of the array from both ends. We'll move both pointers towards the very middle of the remaining array, which is going to be like this. This is the breakout condition. While left is smaller than right index, what we will do is we will have a sum, check whether all of the 3 pointers pointing to one element, and let's see if they're going to add up to 0, right? See if they add up to 0. If they add up to 0, well, that's the happy case. We'll be very happy to add it in, right? Arrays as list, nums I, nums left, nums right. That's the happy case. And then what we'll do is left will move the pointers towards the middle, right, minus 1. Else, if sum is greater than 1, remember this array, it's already sorted. The first line that we do is to sort the array. So in this case, if sum is greater than 0, the only possible third element that we can find could make the sum to be equal to 0 is going to be the one on the left side of the remaining array, right? So we're going to decrement the right index by 1. The only other possible case, which is sum smaller than 0, so we don't even need that. Sum greater than, sum greater than, sum equal than, then the only other case is sum smaller than. So when sum is smaller than 0, the only possible second or third element that we can find could make the sum to be equal to 0, which is to shift the left pointer towards right. Right, to basically move the second point to the right up to see whether we can find a bigger second element to make the sum is equal to 0. That's it. Then this is the inner loop, which we are shrinking towards the middle using left and right pointer, both of them moving towards the middle. And the outside for loop is basically one pointer, which is the first pointer, which is moving from the very left side towards the very right side. That's it. Where's this for loop ends here, so we'll just return result here. This is the algorithm. Then let's think about anything that we can still skip duplicates, which is in this case, right? When sum equals to 0, we just add this one in. But it's still possible that left is going to have a lot of duplicates. So does right. It's totally possible. So use case is going to be like minus 1, 0, 0, 1, 1, 1, 2, right? In this case, all of these ones, okay, let's even include more 2s. In this case, it's totally possible that nums left becomes at this point, And then if we just do left plus plus, it's going to give us a lot of duplicates, which we don't want. That means our solution set is going to end up with a lot of duplicates, triplets, which is not what we want, which is not going to be accepted by the OJ, and it's going to render us wrong answer. In that case, what we want to do is that we're going to skip all of the duplicates. So we'll have another while loop here. Left is smaller than right, and nums left equals nums left plus 1. In this case, we'll just keep incrementing left index, right? So that way we don't contain any duplicate triplets in our final answer. The same applies to this side. So say on the very right side, there could be a lot of duplicates too, which happens. And then we'll also skip all of them. Right equals to right minus 1. In this case, we're just going to keep decrementing right. This way, none of the duplicate triplets will end up in our final solution set. I hope this makes a lot of sense to everybody. If not, please leave me comments down below. Then some people might be wondering, oh wow, this is a lot of nested while loop. So you said in the very beginning we don't want 3-layer nested for loop, which is going to end up as O(n) cubic time complexity, which is horrible, right? But how come you have like for loop, while loop, while loop, while loop? This is crazy, right? But look further into this algorithm. Is this going to end us with O(n) cubic or even O(n) quadruple time complexity? Since we have for, while, we have 4 keywords that's creating loops for us. Is that really the case? If you look further, it's not the case. The time complexity is still, let me type it here, is still O(n) squared. This is the time complexity for this entire algorithm. Why? Let's say here, sorting algorithm, default sorting algorithm is going to cost us nlogn, right? You either use quicksort or merge sort or whatever. It's going to end up as nlogn time. So it's definitely smaller than O(n) squared. Then here, this nested loop is going to cost us actually O(n) squared only. Why? Because let's look at the logic. We start from the very left side, which is the very left side. And then this inner while loop is only going through this array once, left and right. If we just look at this for loop and this while loop, we totally understand this is O(n) squared, right? The confusion comes from there are another while loop here. But if we look further, we can see this while loop, it's just moving this inner loop towards one direction. So does this one, right? So it's only continuing, it's going forward, it's going towards the right. And this one is moving the right pointer towards the left. Whenever left is smaller than right, you see the breakout condition, this inner while loop is exactly the same as the outer while loop. Which means as soon as any one of these while loop conditions don't meet, left is smaller than right, we're going to break out of this inner while loop. So it's just 2 pointers. These 2 pointers are iterating on the same remainder of the rest of the array. So this one is going to cost us O(n) time. This entire while loop is going to cost us O(n) time. That's why O(n) times O(n) is going to cost us O(n) squared time. I hope that makes a lot of sense to you. That basically, okay, let's submit this solution. Accepted. That basically concludes the tutorial, the walkthrough of this very classic interview problem. So if you have any questions, comments, concerns, advice, please leave me comments below. I really appreciate your help. And also, please smash the like button and subscribe to our channel. I'll see you guys in the next tutorial. Thank you very much.